Welcome to Maths Companion. In the last video, we have discussed problems on page 86. There was a homework. An isosceles triangle has to be made like this. The height should be 2 meters less than the base and the area of the triangle should be 12 square meters. What should be the length of its sides? This is the triangle. Given that the height should be 2 meters less than the base. Let us take the base as x meters. Then height is 2 meters less than x or x minus 2. Given that the area of the triangle is 12 square meters, area of a triangle is half into base into height. So we can write half into x minus 2 equal to 12. Let us take 2 on the other side. Then 1 into x minus 2 or x into x minus 2 equal to 12 into 2 or 24. Now let us multiply. X into x is x square. X into minus 2 is minus 2x. So this can be written as x square minus 2x equal to 24. Now this is not a perfect square. What shall we add to make it a perfect square? Look at the coefficient of x. It is minus 2. Let us take 2. Half it. We get 1. Square it. 1 square is 1. When we add 1 here, it's a perfect square. When we add 1 on the left side of the equation, we have to add 1 to the right side of the equation also. So let us write x square minus 2x plus 1 equal to 24 plus 1. Now this is a perfect square. This is the square of x and this is the square of 1. This is negative. So this is the square of x minus 1 and this is 25. So we can write x minus 1 all square is equal to 25. This is the square of x minus 1 and this is the square of 5. So taking square root on both sides, we can write x minus 1 equal to 5. Taking minus 1 on the other side, we can write x equal to 5 plus 1 or 6. X equal to 6, that means the base of the triangle is 6 meters. Then height is 6 minus 2 or 4 meters. Now we have to find these two sides. This is an isosceles triangle and these two sides are equal. Let us consider this triangle. It's a right angle triangle. Since it is an isosceles triangle, the height divides the base into two equal parts. So this length is 3 meters and this is 4 meters. And this is the hypotenuse of the right angle triangle. We know hypotenuse square equal to base square plus altitude square, or hypotenuse equal to root of base square plus altitude square. This is 3 meters and this is 4 meters. Therefore, this side is equal to root of 3 square plus 4 square. 3 square is 9 and 4 square is 16. So we can write this as root of 9 plus 16. 9 plus 16 is 25. So this can be written as root of 25 and root of 25 is 5. Therefore, this length is 5 meters. Hence, this length is also 5 meters because they are equal. Now, the sides of the triangle are 6 meters, 5 meters and 5 meters. In this chapter, we need to find square roots a lot of times. Sometimes we have to find squares also. So let us check how to find squares and square roots easily. Mostly we need squares of 2-digit numbers. So let us find a method to find the squares of 2-digit numbers easily. Let us find the square of 13. The unit digit is 3 and 3 square is 9. So the unit digit of the square is 9. Now let us multiply these two digits. 1 into 3 is 3. Double it, we get 6. And this is the next digit of the square. Now the tens digit is 1 and 1 square is 1. So this is the last digit of the square. That is 13 square is 169. Now let us find 31 square. First of all, 1 square is 1 and the unit digit of the square is 1. 3 into 1 is 3. Double it, we get 6. That is the next digit. Now 3 square is 9. That is the last digit. And 31 square is 961. Now let us find 26 square. 6 square is 36. We can write only 6 at the units place of the square and 3 is the remainder. Now let us multiply the digits. 2 into 6 is 12. Double it, we get 24. Add the remainder 3 with 24. We get 27. And 7 is the next digit and 2 is the remainder. Now the tens digit is 2. 2 square is 4. Add the remainder 2 with 4, we get 6. And this is the last digit. So 26 square is 676. Now let us find 37 square. 7 square is 49. We can write 9 and 4 remainder. 3 into 7 is 21. 21 into 2 is 42. 42 plus the remainder 4 is 46. So 6 is the next digit. 3 square is 9. 9 plus the remainder 4 is 13. So 13 is the next part. So 37 square is 1369. Like this, we can easily find the squares of two-digit numbers, and mostly we need to find squares of two-digit numbers in this chapter. Now let us find how to find the square roots. Mostly we will be given perfect squares, that also with 3 or 4 digits. So now we are going to find a method to find the square root of perfect squares with 3 or 4 digits. The square root of perfect squares with 1 or 2 digits contain only 1 digit. So it is very easy to find the square root of perfect squares with 1 or 2 digits. We know 1 square is 1. That means the squares of numbers ending in 1 also end in 1. 2 square is 4. That means the squares of numbers ending in 2 end in 4. 3 square is 9. Therefore, the squares of numbers ending in 3 end in 9. 4 square is 16. Therefore, squares of numbers ending in 4 end in 6. 5 square is 25. Therefore, squares of numbers ending in 5 end in 5. 6 square is 36. Therefore, squares of numbers ending in 6 end in 6. 7 square is 49. Therefore, squares of numbers ending in 7 end in 9. 8 square is 64. Therefore, squares of numbers ending in 8 end in 4. 9 square is 81. Therefore, squares of numbers ending in 9 end in 1. 10 square is 100. Therefore, squares of numbers ending in 0 end in 0. Now we can see one thing, that 1 square is 1 and 9 square is 81. That means the squares of numbers ending in 1 and 9 end in 1. Similarly, squares of numbers ending in 2 and 8 end in 4. Similarly, squares of numbers ending in 3 and 7 end in 9. And squares of numbers ending in 4 and 6 end in 6. Now, squares of numbers ending in 5 and in 5, and squares of numbers ending in 0 and in 0. Here 1 plus 9 is 10, and the squares of numbers ending in 1 and 9 end in the same digit 1. 2 plus 8 is also 10, and the squares of numbers ending in 2 and 8 end in the same digit 4. 3 plus 7 is also 10, and the squares of numbers ending in 3 and 7 end in the same digit 9. 4 plus 6 is also 10, and the squares of numbers ending in 4 and 6 end in the same digit 6. No need to by heart this. We know 1 square is 1. Therefore, the squares of numbers ending in 1 end in 1. 1 plus 9 is 10. Therefore, the squares of numbers ending in 9 also end in 1. Similarly, we can understand these points also. Using this basic idea, we can find the square root of perfect squares. Let us take an example. Let us find the square root of 289. First of all, we have to make this number into groups, starting from the right. Take 2 digits and form a group. 89 is a group and 2 is another group. So there are 2 digits in the first group, and in the second group there is only 1 digit. Sometimes in the second group there may be 2 digits. Now take this group. 1 square is 1, 2 square is 4. This is more than 1 and less than 4. Or this is more than 1 square and less than 2 square. That means this number is more than 10 square and less than 20 square. That means the square root of this number is in between 10 and 20. So the tens digit of the square root is 1, because it is more than 1 square and less than 2 square. It is more than 1 square, so the tens digit is 1. It is less than 2 square, so the tens digit cannot be 2. Now look at this group. It ends in 9. We know 3 square ends in 9, and 7 square also ends in 9. So the unit digit can be either 3 or 7. That means the square root can be either 13 or 17. How can we identify which is the square root of 289? There are 2 methods. Now you know how to find the square of 13. 3 square is 9, 1 into 3 into 2 is 6, and 1 square is 1. So the square of 13 is 169. It is not 289. Therefore, square root of 289 is 17. That is one method. Another method, we are not sure of the unit digit. It can be either 3 or 7. But we are sure of the tens digit. It is 1. Multiply the tens digit by the next number. Tens digit is 1 and the next number is 2. 1 into 2 is 2. Now look at this group. If this is less than 2, we have to take the smaller digit. If this is equal to or more than 2, we have to take the greater digit. Here this is equal to 2, so we have to take the greater digit 7. That means root of 289 is 17. Now let us take another example. Let us find root of 144. First of all, let us make two groups. 44 is a group and 1 is another group. 1 square is 1, 2 square is 4. So we can take only 1. 2 square ends in 4 and 8 square also end in 4. So the unit digit can be either 2 or 8. The tens digit is 1 and next digit is 2. 1 into 2 is 2. And this is less than 2. So we have to take the smaller digit. That is 2. That means root of 144 is 12. Now let us take another example. Root 256. First of all, let us make groups. 56 is a group and 2 is another group. 1 square is 1, 2 square is 4. So we can take 1. 1 is the tens digit. Now this group end in 6. 4 square end in 6 and 6 square also end in 6. So the unit digit can be 4 or 6. That means the square root can be 14 or 16. Now tens digit is 1 multiplied by the next digit 2. 1 into 2 is 2 and this is equal to 2. That means we can take the greater digit 6. So root of 256 is 16. Another example, root of 324. First of all, let us make groups. 24 is a group, 3 is another group. 1 square is 1, 2 square is 4. So the tens digit is 1. This group end in 4. 2 square end in 4 and 8 square also end in 4. So the unit digit can be either 2 or 8. That means the square root can be either 12 or 18. Now tens digit is 1. 1 into next digit 2 is 2. And this is more than 2. So we have to take the greater digit 8. That means root of 324 is 18. Another example, root 729. First of all, let us make groups. 29 is a group, 7 is another group. 2 square is 4, 3 square is 9. So we can take 2. The tens digit is 2. And this group end in 9. 3 square end in 9 and 7 square also end in 9. So the unit digit can be either 3 or 7. That means the square root can be either 23 or 27. Tens digit is 2 and next digit is 3. 2 into 3 is 6. And this is more than 6. That means we have to take the greater digit 7. That means root of 729 is 27. Another example, root of 1225. First of all, let us make groups. 25 is a group, 12 is another group. 3 square is 9, 4 square is 16. So the tens digit is 3. This group end in 5 and we know the square of 5 end in 5. So there is only one choice and the unit digit is 5. So root of 1225 is 35. Remember one thing, that we can use this method to find the square root of perfect squares only. Mostly we will be given perfect squares. So after getting the answer, if you want, you can find the square and check whether your answer is right or wrong. Sixth problem. A 2.6 meter long rod leans against a wall. Its foot 1 meter away from the wall. When the foot is moved a little away from the wall, its upper end slides the same length down. How much farther is the foot moved? This is the ground and this is the wall. Let the intersecting point be B. A rod leans against the wall. This is the rod. Let it be AC. Its length is 2.6 meters. Its foot is 1 meter away from the wall. That means this distance is 1 meter. Now this is a right angle triangle. The hypotenuse and base are given. Let us find the altitude. We know altitude square is hypotenuse square minus base square, or AB square equal to AC square minus BC square. AC is 2.6 and BC is 1. So we can write this as 2.6 square minus 1 square. You know how to find the square of 26. 26 square is 676. There is one digit after the decimal point in this number. So in its square, there will be two digits after the decimal point. Therefore, the square of 2.6 is 6.76 and 1 square is 1. So we can write this as 6.76 minus 1. Subtracting, we get 5.76. AB square is 5.76. Therefore, AB equal to root of 5.76. You know how to find the square root of 576. The square root is 24. There are two digits after the decimal point in the square. Therefore, there will be only one digit after the decimal point in the square root. Therefore, the square root of 5.76 is 2.4, or AB equal to 2.4 meters. That is, this length is 2.4 meters. Now, the foot of the road is moved little away from the wall. Then, its upper end slides the same length down. Let the road be like this. At these positions be P and Q. The length is 2.6 because it is the same road. Let the distance moved by the foot be x. That is, this distance is x. Then this is also x because it is given that the upper end slides the same length down. Now this is 1 and this is x. Therefore, BQ equal to x plus 1. This is 2.4 and this is x. Therefore, BP is 2.4 minus x. Now look at triangle PBQ. It's a right angle triangle and the hypotenuse is 2.6. Base is x plus 1, altitude is 2.4 minus x. And we know base square plus altitude square is equal to hypotenuse square, or BQ square plus BP square equal to PQ square. BQ is x plus 1, BP is 2.4 minus x, and PQ is 2.6. Replacing the values, we get x plus 1 all square plus 2.4 minus x all square equal to 2.6 all square. X plus 1 all square is x square plus 2x plus 1. 2.4 minus x all square is 2.4 square minus 2 into 2.4 into x plus x square. 2.4 square is 5.76 minus 2 into 2.4 into x is minus 4.8x and plus x square. 2.6 square is 6.76. So expanding, we can write x square plus 2x plus 1 plus 5.76 minus 4.8x plus x square equal to 6.76. X square plus x square is 2x square. 2x minus 4.8x is minus 2.8x. 1 plus 5.76 is 6.76. And when we take 6.76 on the other side, we get 6.76 minus 6.76 and that is equal to 0. So we can write 2x square minus 2.8x equal to 0. Now we can divide each term by 2. When we divide 2x square by 2, we get x square. When we divide minus 2.8x by 2, we get minus 1.4x. When we divide 0 by 2, we get 0. So we can write this as x square minus 1.4x equal to 0. Now this is not a perfect square. What shall we add to make it a perfect square? Let us look at the coefficient of x. It is minus 1.4. Let us take the number without sign, that is 1.4. Half it, we get 0.7. Square it, we get 0.7 square. So when we add 0.7 square here, it becomes a perfect square. When we add 0.7 square here, we have to add 0.7 square on the right side of the equation also. So adding 0.7 square on both sides, we can write x square minus 1.4x plus 0.7 square equal to 0.7 square. Now this is a perfect square. This is the square of x, this is the square of 0.7 and the middle term is negative. So this is the square of x minus 0.7. So we can write x minus 0.7 all square equal to 0.7 square. This is the square of x minus 0.7 and this is the square of 0.7. Taking square root on both sides, we get x minus 0.7 equal to 0.7. Now let us take minus 0.7 on the other side. We can write x equal to 0.7 plus 0.7 or 1.4. X equal to 1.4. That means the distance moved by the foot is 1.4 meters. So we have completed the section square completion and we have done all the problems on page 86. We shall discuss the next part in the next video. Till then, bye.